Hello. Hey, sorry, I know it's been a minute, but I am back and I've got some updates for the channel. Long story short, I moved across the country and it took a lot longer to get settled than I was expecting. The first major announcement that I'd like to make is this. This is Breaking Taps, a transport-triggered architecture microprocessor that I designed myself. It's currently being fabricated at Global Foundries using their 180 nanometer process. And I don't have dates yet, but we're expecting to get the chips back sometime this spring. I use a service called wafer.space, which is a new multi-project wafer service run by a guy named Tim, who's really big in the open source silicon world. Basically, you submit a design and it gets grouped up with a bunch of other designs onto a single wafer. They're gonna get the wafers back and dice them up, package, and send them out. So sometime this spring, I will have a whole bunch of chips that I designed, and hopefully it'll work and we can document the process here on the channel. Now, I've never done anything like this before, not even programming FPGAs, which is kind of the intro to hardware design. So it was a really steep learning curve. And I did it under a pretty tight time constraint because I needed to meet the tape out deadline. So there is a non-negligible chance that this thing has some kind of catastrophic bug and it comes back dead on arrival, which admittedly would kind of suck. But even if that happens, I think it's still going to generate a lot of really interesting content for the channel because I'd like to talk about the whole process from beginning to end. Like, how do you design a chip? What are the optimization techniques used? What's the tooling that takes your digital design and turns it into transistors? And how do you verify all that? What happens when you get the silicon back? Like, what's the bring up process look like? All that stuff I think is really interesting and deserves to be talked about even if the chip itself doesn't work. But I mean, hopefully the chip works because that would be better. And also I'd be really sad if it doesn't. So I was getting tired of seeing my head talk on video. So we're gonna go for a bike ride because I need some exercise and it'll be a little better scenery. Let's do it. While we're waiting for the silicon to come back, we can get a jump start on the next bits and pieces. So for example, I'm working on an IDE to make the assembler process a little easier to handwrite. Transport triggered assembly is sufficiently different that it doesn't really make sense to reuse an existing IDE. For example, we've got 2 operations at each clock cycle because it's double bus, and you really care about timing because that's how TTAs work. So for that reason, I'm starting to work on a little custom IDE. Nothing fancy, but something makes life a little easier. Oh, I don't want to go that way. Do not enter, yeah. At some point, I would also like to write a little compiled language that compiles down to the TTA assembly. Then we could explore some of the more interesting things you can do with a TTA, like optimizing when and where you use functional units. And we'll talk more about that later when we get there. Ah, shoot, I took a wrong turn. I didn't want to go this way. I want to go that way. Do I want to go that way? So that's the silicon project. I'm not going to make any more videos until I actually get the silicon back. I think the types of content that we make will depend basically if the chip works or not. If the chip's dead on arrival, it'll look very different than if we're like programming the thing. Should I go on that trail? Let's do it. So with that paused, I'm starting to think about what next projects I want to do in the channel. And I'd like to do something kind of long-term, just so I can sink my teeth into it. And it's also a little easier given my new situation, which is that I don't have much of a shop left anymore because I sold most of it when I left. So any hardware projects we work on will have to be something that I can outsource pretty easily. And that does change the type of projects we work on and the speed they happen. You might have noticed at the end of last year, or at least when I stopped working on videos sometime last year, that there was a distinct space theme to a lot of the videos. And if you're on my Patreon, you definitely would have noticed the post I was making about a Cubesat project. That was kind of my long-term plan at the time that I was just getting started on, was building and hopefully launching a Cubesat someday. And now, I know it sounds kind of crazy, and it honestly is a little crazy to think about complexity and logistics involved in doing something of that magnitude. But from talking to people that have launched them before or been involved in projects, it doesn't seem insurmountable. Obviously a lot of work, needs a lot of dedication, but the budget shouldn't be too bad. Like, I think I can cover it with revenue from the channel, which is cool. And you know, it's something that university groups build and launch all the time. So it is entirely doable for someone that's committed enough to do it. I've got a couple ideas for mission payloads, if you will, like what the CubeSat will actually want to do. So my plan at the end of last year was to work on basically an amateur astrophotography satellite. So put a little image sensor in there, put a little telescope, give it an ability to track the stars and point in specific locations and take cool photos. All right. Now, an imaging telescope or an imaging satellite is definitely on the more ambitious side of the spectrum. There's a lot that has to go into making that work, just at all. It's got a pretty high power budget, needs good bandwidth for communication. You need star tracking and good attitude control so you can point at targets and image them consistently. There's a lot of extra regulatory hurdles if you have an image sensor, because, you know, governments don't like you spying on people, unless they're the ones doing the spying, that is. So yeah, it would be a pretty big project, but the payoff, man, would be so good. The birds are busy today. Take a break here and watch the birds, I think. I learned recently the little black ducks, that is actually coots, not ducks, and they're related to chickens. So how's that for a cool bird fact? The second idea I was thinking about working on for a CubeSat is basically leveraging this newfound custom silicon knowledge that I have and making some kind of custom chip, sensor, device, whatever, to go on a CubeSat, which I think would be really cool. So the first one that obviously springs to mind is a space or radiation hardened chip. There's a lot of really cool techniques in space hardening of digital circuits that we could talk about. So for example, any circuits that are on the chip that are pretty critical, you triplicate them, so you have the same circuit in 3 different physical locations on the chip, and then they all vote on their answer. And that lets you get kind of redundancy built into your chip, as well as letting the software know if something has gone wrong. You can kind of detect and fall back to unknown safe mode. So tricks like that, and there's a lot of neat stuff you can do. A space hardened chip is also kind of a cool idea because there's the software side and the firmware side. And in both of those cases, you do similar tricks like voting and error checking, parity checks, that sort of stuff for a space environment. So it'd be a neat kind of holistic project of designing custom silicon that we launch into space and have designed and built the whole stack from the silicon up to the programming, the software. So that's really appealing to me. I think that'd be a really neat project. We're gonna tap out, go back to the comfortable sitting at home narration, because I'm just gassed right now. Another idea that I had is to make a high energy particle detector array or volume. When a proton smashes through a piece of silicon, it liberates a bunch of electrons, which you can capture in dedicated circuitry and detect kind of a proton that's passing through that part of the chip. So the general idea is you make a chip that has an array of detector features, some relatively simple analog circuitry to collect those electrons, amplify them, and then read out a signal, as well as some like temporal timestamps so you know when it happened. You take that chip and you tile it into an array of chips, and then you take those arrays and stack them, and now you have this like 3D volume of detectors that can trace protons as they go through the volume and give you some amount of information about energy of the proton and then the direction roughly about where they came from. That is a crazy amount of seagulls. No, they're pelicans? Are they pelicans? Oh my gosh. No, those are pelicans over there. Okay. Off to my left, I think those are all the seagulls. What's a flock of seagulls called? A chum? I don't think that's it. And then the last project is another custom silicon project that I'm thinking about because it's kind of in the news right now due to AI stuff. And I don't particularly care about AI or LLMs or any of that, but it has exposed some interesting silicon computing architectures to the mainstream, which I think is cool. So there's a type of chip called a CGRA, coarse-grained reconfigurable array. It's kind of like a spiritual cousin to an FPGA. So an FPGA is programmable, works at a bit level, so bits kind of flow into the mesh, and then you assign different operations at each kind of node in the mesh, lookup tables or flip-flops or logic elements, stuff like that. And it takes the bit in, does whatever it's supposed to do, and spits a new bit out. That's an FPGA. And they're great, they're super flexible, but performance is to some degree hampered because you're working at a bit level. So a CGRA kind of takes that idea, but instead of working with bits, you work with whole words. So 8 bits, 16 bits, 32 bits, I don't know, 19 bits, like whatever you want. And that number of bits all flow into each unit, and then you perform some operation on it, like a arithmetic unit or a matrix multiplier, or a multiply and then accumulate, whatever your operation is. But since it's working at kind of the word level, you get just a lot more performance because you can cram more bits through faster. The downside, of course, is it's less flexible because you're kind of limited to the functional units that you've built into it and the words that they operate on. Whereas at a bit level, you can basically build anything you want. It just might be a little slow. So this has gotten popular or more mainstream recently because there's a company called Groq, G-R-O-Q, and they've got a thing called an LPU. I think it stands for Language Processing Unit. It's not a CGRA, but it's conceptually similar to a CGRA, an advanced CGRA. The AI folks like this because it's programmable, so you can change it up depending on what model or what part of the model you're trying to execute. But it's higher performance than the FPGA, which is obviously important for the sort of AI workloads right now. Like I said, I don't really care about the AI stuff, but I do think it's a really neat architecture. It's also not something you can just buy off a DigiKey right now, which is interesting. You can go buy an FPGA either as a device or as a dev board, but you can't really buy a CGRA outside of like academic chips that some lab made a one-off of. I suspect because it falls in an awkward middle ground, right? It's not nearly as flexible as just a generic processor. It's not as high performance as a GPU for just raw matrix operations, or DSP for that matter. Let's go this way. It's not as flexible as an FPGA. It's probably just kind of in an awkward middle ground. I suspect that's why it's not super common, but it's my chip, I get to do what I want, and it's not high performance anyway because it's on this legacy node. So might as well have some fun with it and make some kind of weird esoteric architecture. So yeah, that's kind of what I'm thinking. Those are the various options on the table for projects on the channel coming up. If you've got opinions, I am all ears. Either custom silicon projects or Cubesat projects, let me know. All right, I think that's all I got for you. Thanks for biking along with me. Hopefully the wind wasn't too bad. I'm gonna take the short way home and fight traffic. So, peace. Oh, this wind. This is gonna be a tiresome trip today, I think. All right, well, it's windy today. Oh, this wind, brutal. I should record how many times I complain about the wind. Working on silicon, and boy, it's harder to think while biking. Oh, this wind. Oh my God, this wind. Oh, this wind. Man alive. Ooh, that wind.